Hello and welcome to the Analysys Mason podcast. My name is Christopher Baugh. I am a partner at Analysys Mason and head of our space research practice. Once again, my delight to welcome you to, I believe, one of the more interesting and dynamic topics, which is space and orbital data centers. And we're positioning this topic as orbital data centers. Do they provide a viable alternative, maybe complement, to the terrestrial data center world? I'm very pleased that I have two very senior speakers to talk about this topic today. We're going to look at it from two different angles. The first angle is a terrestrial side, and we have Simon Sherrington here, who's one of the leads on our data center reporting and analysis within the research team. So Simon, welcome to the podcast.
Thank you. Great to be here.
Thank you. And Claude Rousseau, who is also a research director, part of my team, and is going to look at it from the space side in the orbital data center world. So one side, ground looking up. Claude's going to be space looking down, trying to find out where this new dynamic of orbital data centers are a potential fit, and when and how and all of that. But the first question, I'm going to come to Simon because so much is happening on the ground and we have a lot of new data in the company around this specific market. So Simon, can you, for those maybe unfamiliar with the explosive growth happening in the data center world, can you give some context for what's happening currently, why it's happening, what's driving it?
Yeah, sure. Absolutely, Chris. Yeah, I mean, as you mentioned, we've just launched our new data center data module, and we've developed an enormous amount of information, collected an enormous amount of information about this market. And the quite frightening thing about the data center market is the sheer scale of activity that's taking place. There are already around 4,500 data centers. If you just look at Europe and the Asia Pacific, for example, we're aware of another 500 or so being built. There are hundreds of sites being developed. Some of those are absolutely astronomical in scale. The challenge, I suppose, for the industry is trying to be able to supply all of the capacity that is anticipated will be required.
Interesting. So it's a supply. Is it a supply constraint more than anything? It's not a demand constraint in the data center market.
Well, it's an interesting question. I mean, a lot of the investment is being put in place because companies and governments around the world all want to play in, what you might call the AI future. They need to have, as far as they're concerned, the facilities and the capabilities to leverage AI to drive their businesses or their economies forward. AI requires an enormous amount of compute capacity, and that all needs to go somewhere. And the scale of compute required to train large models to provide inference-related services is pretty large. It's changed the scale of data centers, probably by an order of 10 over the last few years. And the industry really has a challenge now in terms of finding sites where they can put these facilities, getting access to the power that's required at those facilities, access to the water that's needed for cooling. So there are a variety of environmental challenges to meeting the requirement. Now, a lot of those data centers are being built to order, so in theory they won't be empty, but of course it is reliant on the economics of AI bearing fruit and actually the capacity being required in the future. I mean, you could take a view on that. I think it's likely to be a given. The specific form of the future may not be what everybody's anticipating, but the capacity is going to be required.
Interesting. And you mentioned some challenges, and this is maybe a nice segue to you, Claude. I saw a data point recently that blew me away. 7% of electricity consumption in the US is for data centers at the moment. And we can debate it's up or down, but it's not a small amount. You think of the consumption in general, and this is the US, perhaps the most advanced, I'm assuming, for data center deployment. I mean, these are challenges, and we've seen some states pause deployment. We've seen some, it is definitely, I think the public's waking up maybe to some of the impact of this growth. And it sounds as if, and I don't know where the rest of the world is behind that, but again, it's not going to stop it entirely, but it seems like back to the challenge of finding the real estate, finding the electrical grid, finding everything to continue that pace. So that is something I think you're considering, Simon, in your analysis and kind of thinking about what that forecast curve looks like.
Yeah, absolutely. And we've seen projects being delayed in Europe as well. Some very high profile examples of large-scale Amazon facilities being delayed in Ireland because of limits on the power infrastructure. And some of these developed sites are hundreds of gigawatts planned for individual campuses. They are enormous projects. planning and lead times for developing the grid infrastructure to supply those sorts of sites takes many years and an awful lot of money. So it really does slow down the ability of organizations to put their infrastructure where they want it. And we are seeing, as a result of that, investment in new locations where companies can still access land, where they can still access power.
Very interesting. Great segue to you, Claude, which is perhaps an interesting solution to some of these challenges of space. And we have billionaires and perhaps trillionaires driving a lot of the debate here, and millions of satellites or more. It's remarkable. So, Claude, can you give to the audience again the why space? Why is this taken so much? And we do a lot of surveying, and I'll give one data point. It's one of the top 4 or 5 questions our clients are asking us, right? What is driving this? Is it real? When will it be viable? When can I expect my workflows to go through space? Can you give maybe some context to that and where space fits in this debate and when and how kind of thing?
Yeah, you mentioned that statistics, and I saw that statistics actually could be double in 3 years' time. So it depends who you believe here, but definitely for terrestrial data centers, there's a lot of challenges. The interest you mentioned from high profile entrepreneurs over the last 12 to 18 months has risen the profile of space data centers, although it's been around for quite a few years now, I mean, 4 or 5 years for sure. And the filings from some of those data center operators, for thousands, if not a million, data centers in space, like SpaceX did recently. And I think that interest is mainly because they are trying to also address the same challenges, or actually challenges cited by Simon for terrestrial DCs. And basically saying, well, we can be a solution to some of those problems, the power, the remoteness of locations, free at real estate, basically. So those are all the reasons why we're hearing more about space data centers. But the challenge is that it's not easily done. There's a lot of specific use cases that we believe will form first and that will better target space DCs, such as, storage of very highly classified information. Redundancy is one major area where if you have some data that you really need to keep a second or third copy of, you'll probably have an opportunity to do that with a space data center. The processing, of course, if you want something to be securely processed, yes. AI models, support and training, that's all part of the picture, and as well as edge compute that we're hearing more and more about because people are now using distributed architectures. And that's mostly, I would say, for government, but on the commercial side, you still have also some very interesting use cases that can be run over space data centers, which is, for example, transactions, financial transactions. We've seen a lot of folks also extending their cloud compute processes in orbit, and as well AI model training. A lot of this actually, though, needs to recognize the fact that, for example, AI chips, those that are running AI models, take 14 times the power of a regular chip, at least, or somewhere around there. So I would not say, though, that space data centers are better, are having clear advantages, but there are certain types of areas where it's really clearly a good choice. For example, putting data in a remote location. Well, space is, it's a couple of 100 miles up above, and that really is a hard to reach location. The economics overall, though, are based on cheap launch, really cheap launch, very high production rates if you want to put millions of them up there, and then harnessing free solar power at a very high efficiency, because right now we know solar cells are not very efficient. And then again, quick turnaround. That was mentioned as an obstacle by Simon. You could probably build a satellite, space data center in 12 to 18 months and launch it very quickly, and then have that considered as part of the economics of your space data center. So I would say that all of these use cases and all the high profile mentions that were made, plus solving some of the challenges of terrestrial data centers, has made the profile of orbital data centers really high.
Okay, very interesting. And as I mentioned, these are space telecom clients asking us about orbital data centers, ODCs. So it's a big topic. I think when you rationalize it, you mentioned the key thing, and I'll pull you both into this conversation, which is economics, because you mentioned SpaceX and 1 million data centers. I mean, it's just a nice round number, isn't it? It's kind of almost too perfect, right? And we know that SpaceX is up for an IPO any day, any month, whatever now. So of course, there are stories to be told in the run up to any public offering. But again, this has to be done at scale to really matter, minus the few satellites here or there that may have NVIDIA sort of process, whatever. I mean, we have to star cloud these others that are getting funding now. So economics matter. Claude, you mentioned launch. the building cost, what capacity can put to orbit. This isn't going to be easy. So how far off? And maybe Simon, we've taken it in terms of power. It's obviously, it's a big gulf at the moment, but how far off? Is this even a reasonable assumption to assume this can be done at scale with a reasonable economic model behind it in space?
Well, it's say the $1 million question. It's probably the $1 trillion question, isn't it? I think one of the interesting things is that the cost of deploying terrestrial data centers is absolutely enormous. So if you look at the SpaceX ambition to put in 100 gigawatts of capacity a year, in terms of terrestrial deployments, that's going to take 5 years to achieve that. It's probably going to cost, based on current prices, somewhere between $2 and $4 trillion to have that sort of data center capacity built and occupied with the IT equipment and infrastructure inside it. So that's in no way a small amount of money. But if you just think about the launch costs for 1 million satellites, I mean, we've had conversations about what the possible weight of those might be. But if you assume that they're maybe somewhere between 50 to 100 million tons for that many satellites, you might be looking at $3.5 to $7 trillion just for the launch cost of those satellites without having to build them. So although there's a lot of movables, a lot of variables there that you have to take into account, that makes them look expensive in comparison with terrestrial solutions. And then of course you've got the cost of the satellite itself on top. But if the economics can be changed, if the stuff can be launched really cheaply, then, it's not X, the cost of, terrestrial-based infrastructure. It's a little bit more when you're talking trillions.
Well, yeah, true. It's just monopoly money, as they say now. So at the end of the day, so again, this is a challenge, and there are many, I think, challenges along the way here to building in space. But Claude, your side, from the space side in economics, we've run a number of models, whether it's launch, building, maintenance, all of it, to do this at the scale that you're seeing these numbers. Where is the challenge? Where are the real pain points in this process to get it to as Simon mentioned, a bit more than 10x or 20x, maybe?
I'll say the first challenge is money. So that's the first one. And I also, have to note that investors in terrestrial data centers are in for the long run. And therefore, I would say that investors for space DCs have to be in it for the long run for various reasons, but it costs a lot. So far, I'll be honest with you, it was a bit of a downer to realize that there's only been around $240 million announced in investments in space data centers announced. Okay. To gain that scale, the orbital data centers, in my mind, will need superior elements to also that make it work, not just the money side, but also on the technical side. And for that means thermal control, very high power generation, solar panels, flexibility of the software as well. That's coming. I think that the industry is really getting their hands on with software-defined satellites, and they're able to, send updates and patches and stuff like that to, make missions go smoothly or even change. And eventually we call this the modular approach. This is a concept that's really, right now anyways, gaining a lot of interest and traction, because that means you can send modules, you can replenish your constellations, and you can send basically upgraded hardware and on a regular basis so that you're always keeping up, because this is the thing also, AI will make things advance. And as they advance, the chipsets will need to also advance with that technology. And let's not forget that satellites also have a finite lifetime. So at one point they'll be deorbited, so you'll need replenishment and you'll probably need repair. Eventually you might have upgrades of those in space. So that's all going to have to be figured out in the picture, but that's also related to demand for chipsets and processors. And unfortunately, the space industry is not a very large industry, and they need to have those chipsets and processors at a really good discount or a good rate. But the problem is that many of them will need to be radiation hardened for space, and that costs money. That can just shoot up your cost of your spacecraft by a lot, just having radiation protection, because unfortunately, as you go up above the atmosphere, radiation hits the Earth at an order of magnitude higher, basically. So it costs a lot. And on the flip side, this, I think, is going to help drive a lot of new technologies if the money is there, of course. And those challenges, we think, will help bring disruption in thermal management, power generation, batteries for panels, and in orbit services as well. So we believe these are all very positive outlook for space data centers.
Interesting. So again, the story is unfolding. I think we're in the very early stages of it. But I want to ask perhaps to Simon and both but Claude, maybe perhaps a cheeky question. Do economics maybe not matter as much? And the reason why is you have Elon Musk with perhaps going to be the most valuable public company in the world soon, line out the door to invest. Amazon plus the deep pockets, wrapping that sort of into their sort of hidden in terms of their P&L of what this all represents. And the knock-on effect is everybody else, StarCloud, all of the others who are trying to launch. When I think about those two big names, right, the Amazon, SpaceX names, it seems as if, economics matter, but maybe it's not as if you're not bootstrapping to get this done in space. So maybe Simon, to your side, does it matter as much? And also, how does the terrestrial world even see all this? When they look up, I'm sure they're aware of it. I'm sure it's big names throwing out big numbers. Is this kind of a dismissive, no big deal thing? Or is this wow, that's really something we should pay attention to?
Well, I suppose deal with your first question, does economics matter? I suppose if Mr. Musk is prepared to find the money to put, let's say, tens of thousands, if not millions of satellites up there, he will probably find a way to do it. He's that sort of person. So it may be that an economics doesn't matter approach gets you some of the way. I mean, there always comes a point where you've got to make some money out of these things, though. How does the ground-based world see this? There are lots of varying views. I've seen some balanced commentary talking about where there might be specific applications, and I've seen other commentators describing orbital space centers as snake oil. So it really goes in a variety of different directions. I mean, I think probably the truth of the matter is there are things that satellite-based communications can do that terrestrial-based communications can't, and there are markets where you can command a premium for delivering services because of that. And I suspect it will be the same with orbital-based data centers. There'll be some things that cannot be served from terrestrial data centers, whether they're in central locations, whether they're located on their edge compute facilities located on masts. They're not going to be able to help a ship with a low latency service in the middle of the ocean. There'll be remote places on land that they can't serve. So, I think there are always opportunities and segments that can be served and where a premium can be charged for services.
So you subscribe to the kind of like the terrestrial world where satellite broadband are now direct to device. It's one of those things where it fits a need, mainly outside of coverage, mainly outside of as a complementary feature. Broadband can be considered increasingly competitive, not in urban areas, but you understand it's kind of so that you do foresee a fit potentially, no matter when it happens, for there will be applications or use cases or lots of big money behind it, like SpaceX, that there would be a fit for this in the broader data center scheme.
Yeah. And also, I think, it's not just the terrestrial market that these orbital data centers are serving. There's a space industry. There are all sorts of activities happening in Earth's orbit. There are ambitions to get to the moon and beyond. You need compute capability in space. And the more you've got, the better you can run your operations. So it's not about funding these things just from serving people's requirements down here on the ground.
Interesting. Okay. So almost like, again, pie expansion in some ways too, in addition to being complementary. So Claude, final comments here. I mean, a lot what happens in space, you say shifts to the right. Everything takes more time. Launch takes more time. Everything kind of when and are we bullish, bearish, somewhere in between on this prospect for ODCs in the next, say, 1, 3, 5 years?
If I were a betting man, I would say 3 years, maybe 5, but most likely it'll be 7, 8 to really get the scale. And the reasons why is that it's not going to stop because it's a natural evolution of computing, as mentioned by Simon. The moon, the Mars, exploration, either habitat or infrastructure will need compute power. So it's a natural evolution of that for both space and terrestrial market. Space actors, of course, are a bit late adopters of certain types of technologies that we have here on the ground, but we should expect them to flourish. And I think the only question that's really indeed, needed is identifying that sweet spot. And some of those sweet spots may be in data sovereignty, maybe in security of data, but also in space operations. In other words, serving ourselves in the space industry with better compute power. And if you take the example of, communications to and from the moon, when the next person lands on the moon, we'll want to have a 4K to 8K link to see clearly what's happening there. We can no longer go back to that home video or home cinema, experience of 1969. That requires new infrastructure. Same thing goes with the habitats and the infrastructure is going to be developed for the moon and Mars, we will want that compute power available then and there, not, 2 or 3 years later. So we expect that to be a good first case. But then I come back to the conditions, what we believe are needed: cheap launch, high production rates, a lot of good solar power, a lot of available, and not, it's available, but something that can be used, and then quicker time to operation so that we are not able, we're able to recoup the investments faster or in a reasonable time frame. So that will really differentiate the space data centers from the ground base. And then if we don't think it's fully defined right now, what's the intersection between the two of them? But I do see clear advantages in certain markets. But again, it's hard to pin down a market that's so emerging. And when you look at it, really is compared to the ground segment, not much is happening. But fortunately, our industry is moving faster and faster over the past few years, and I don't see that going down.
You mentioned a number, which I'm not going to hold you to, 7 years. And it's interesting because that splits between two data points. Elon Musk says 3 years, and the Google CEO says 10 years, that ODCs are going to be widespread. So I think it went right down the middle, which is nice. And there was a lot. This is the tip of the iceberg, as they say, in this topic. So I know you have a report coming out very soon, Claude, on this topic, and some other sort of you'll see from the Analysys Mason team. Fascinating topic. I want to thank both Simon and Claude both for giving their perspectives on something I think we together, because we as a firm look at all of this. We don't just look at space in a vacuum, literally, but we're looking at everything together as one integrated critical communications piece. So we'll come back more to this. Simon, would love to have you on again on the space side, and maybe we'll jump into one of your telecom podcasts sometime in the future. So
sounds good.
With that concludes our podcast. I want to thank the speakers. And there is more on this content on our site, on the research side, both on the terrestrial side. Simon mentioned a big data set that we've just produced, and it will be expanded further and further on the data center market on the ground. And then on the space side, Claude and some of our team developing space research on this topic specifically. But again, if you want to subscribe, please go to the Analysys Mason website for seeing future podcasts on this and other topics. Thank you. Have a great day.